So you sent this request, you get a response, book not found, but somehow your API still sends it's 200 okay, and then added an error message in the body, and everything is everywhere. That's the thing about API design. You can pick the right architectural type of API, you can pick the right access type, and you can still build something that will make developers' life very miserable. The difference between an API that developers integrate in minutes and the one that makes them want to throw their laptop out of the window is the design. I have previous videos on architectural styles of API, access types of API, but this one is about API design best practices, the craft of building API as well. In this video, we'll be going through each of these design practices: URL design, status code, error handling, pagination, idempotency, rate limiting, versioning, and time to first success call. URL design. The foundation of good API design is the URL structure. And the rule is simple. URLs are nouns and the HTTP method are the verbs. So the URL is the thing and the method is what you do. Can you see the bad ones? They repeat information that is already in the HTTP method. If the method is get, I already know you're getting something. You don't need get in the URL. If the method is delete, I already know you're deleting something. You don't need delete again in the URL. I do this too. I make this. So the good ones are the clean ones. The URL is the resource and the method is the action, and that's it. Now, another rule is also to use plural nouns for collection. So books, not book. This is a strong convention. Everyone does it. So the collection has to be plural. An individual item is accessed by ID under the same plural part. And in the case of relationships, we nest one level deep. So this is correct, and this is wrong. If you need to go deeper than one level, then you flatten it or you just use the ID directly. And another rule, of course, when it comes to URL is to use query parameters for filtering, sorting, and pagination. Don't use the URL part for those. This is not correct. This is correct. The part identifies what you want, and the query parameters refine it how you want it. Second is status code. Status code is the most common mistake in API design. Returning 200 okay for everything, including errors, shouldn't be. Sometimes you see an API that returns 200 with a body that says success, false, error not found. Doesn't make sense. HTTP status codes exist for a reason. Use them. If the request was not successful, there is no reason to return 200. And the status codes are simple. For success, we have 200 okay, 201 created, 204 no content. And for client errors, we have 400 bad requests, 401 unauthorized, 403 forbidden, 404 not found, 409 conflict, 422 unprocessed entity, 429 too many requests. And for server error, we have 500 internal server error. The reason this matters is not just for developers that are reading the response, but you need it to be correct also for monitoring tools, API gateways, load balancers. All of these things use status codes to understand what is happening. So if everything is returning okay, your monitoring will think everything is fine when everything is actually not fine. So please use proper status codes. Error handling. Speaking of errors, there is a modern standard for how API should format error responses. It's called RFC 7807. It was replaced by RFC 9457 in 2023. And as of 2026, this is what you should be using. The problem that this standard solves is the issue of every API having to write or invent its own error format. So you keep coming across different error formats, but RFC 9457 standardizes it. So look at the standard here. Type is a URI identifying the kind of problem. So its title is a short summary. Status matches the HTTP status code, and detail is the specific explanation. Then instance is the URI of the specific request. Also, for the error, the content type changes. Instead of application JSON, is now application problem JSON. So it signals to any client's library that understands the standard that this is a problem details object. And for validation errors, the standards look like this. If your API follows this standard, any framework that understands this RFC 9457 standard can pass your error automatically. Most node libraries support it, and it's kind of like the expected baseline now. Another core thing to note for errors is to never expose internal details to your error response. In your error response, rather. Even if there's an error and you're sending a response, there should be no SQL error inside. There should be no file path. Those kind of error belong in your server logs, not in your API response. That's like a security issue. And then pagination. If you have a get endpoint that returns a list and you don't paginate it, it would eventually crash one day. Say our bookstore API has 500,000 books and someone calls get book with no limit. The API is going down. So the rule is simple. Don't return unbounded list. Always paginate. And there are several approaches to pagination. We have offsets. Limit pagination is the simple one. It goes like this. If you're saying skip the first 20, give me the next 10. It's that simple. You can jump to any page, but it has two problems. It can get slow on large tables. And if data is being added or removed while you are paginating, you can see duplicates or you can miss records. The modern one is cursor-based pagination. So in this case, the cursor is an opaque token, usually base 64 encoded, and the server uses it to figure out where to continue from. It's really fast on each data set, and it's really stable when data is changing. The only downside is that you can only go forward and not backward. But honestly, in most real world scenario, you probably don't want to go backwards anyways. I think Stripe uses cursor, GitHub uses cursors. But if your data set is small, maybe like an admin dashboard where users will want random page access, then you could use offset. But in most cases, cursor is the modern standard. Idempotency, this one is my favorite. If you don't take anything from this video, please take this one. Let me create the scenario of the problem that it solves. Imagine network is unreliable. A client sends a post request to create an order. The server processes it, but the response gets lost. The client does not know if it succeeded. If they retry, they might create the order twice. If the order involves a payment, congratulations, you just charged somebody twice. And that shouldn't be happening. The solution is idempotency keys. So the client generates a unique key, usually a UUID, and then sends it with the request. The server checks, have I seen this key before? If yes, it returns the cached response from the first time, so it doesn't reprocess. If the server checks and see that it has not seen the key before, it processes the request and then caches the response keyed by that idempotency key. Stripe is kind of like the industry reference for this. They use an idempotency key header on all post and delete requests, and the key lasts for 24 hours. So it's simple. Client generates a UUID, server stores the response for that UUID key, and if you retry, you get the same response. And another quick thing to note here is get, put, and delete are kind of already idempotent by design. So calling delete twice on the same resource doesn't delete it twice. It's already gone. Post and patch are where you need idempotency keys because calling post twice will create two resources. Rate limiting, protecting your API. You can think of rate limiting as protecting your API from itself. Without rate limiting, a buggy client or a malicious attack can take down your entire API. So always rate limit. The standard is to communicate limits through headers like this. That way the clients can see it. I have 100 requests per window. I've used 33. The window resets at this timestamp. And when they exceed it, it returns the status code 429, the too many requests, and it returns it with a retry after header that tells them to wait. There are many algorithms for rate limiting, but what most public API use is the token bucket. So the idea is that the client has a bucket of tokens that refills at constant rate, and each request costs one token. If the bucket is empty, you're rate limited. So it enforces an average rate over time, and it's kind of natural to use. Now, versioning. Your API will change. There will be new features, there will be breaking changes, there will be deprecation. You need a versioning strategy from day one. You cannot just be updating things that will be affecting people somewhere. The most common approach, the most popular, and the one that I would recommend is URL versioning. It looks like this. This is what Stripe uses, what GitHub uses, what Twilio uses. It is visible, it is easy to test, it is easy to route. It is common. You will usually see things like this. The alternative is header versioning, where the version is in a custom header or the accept header. In that case, you don't have to show the version in the URL, but then it is harder to test and is less obvious for developers. And I think Stripe does something very interesting. They use date-based versions instead of just numbers, and that is really good for large-scale APIs. And the last one is the time to first successful call. The measure of a well-designed API is the time to first successful call. How quickly can the developer sign up, read the docs, and make their first successful request? The faster that time, the better your API is designed. Everything we talked about today, clean URLs, proper status code, standardized error, pagination, idempotency, rate limiting, versioning, all of it goes to make the developer's life or whoever is implementing your integrating your API's life easier. So API design is pretty much empathy for the other person on the other side of the request. So if the developer can guess your endpoint structure, it means that you designed the URLs well. If they can safely retry a failed request, it means you've implemented idempotency well. If they can get a clear structure error when something goes wrong, it means that you have handled errors well. If you can handle scale without their integration breaking, it means that you did pagination and rate limiting right. So that's API best practices. If you haven't watched the first two videos in this series, the architectural styles video and the access types video, please go and watch it. The links will be in the description box below. Please drop your comments and share and like and subscribe and turn on notifications. See you in my next video. Bye.